Hello and welcome to this coffee break course on JavaScript refactoring techniques. Now I'm assuming that you're already familiar with the benefits of refactoring. As a JavaScript developer, we actually read more code than writing it. So obviously, we should be doing something to simplify the code we write and also make it easier for others to understand. Refactoring, more than being a best practice, is actually a discipline we need to inculcate in ourselves. So let's look at a few different techniques we'll be using to simplify the JavaScript that we write. I'll show you 7 different techniques in which you can simplify the JavaScript code. And for all of this, we'll be using the ES 2015 syntax. So let's start with the first one, creating HTML using template strings. Now constructing HTML in JavaScript to fill a DOM element is something commonly done. And in the past, you must have used a technique like this where we could just construct strings by concatenating with the plus operator. Of course, you can also use the array.join method where you create an array with a bunch of strings and then join it together. This gives you a much better way to manage the strings, but it's still a little cumbersome. In ES 2015, you have the option of using template strings. Using a pair of backticks, as you can see over here, you can construct a multi-line string and interpolate variables from the surrounding context using the $braces syntax, as you can see over here again. And you're not just limited to variables, you can also interpolate complex expressions right inside the $brace. But of course, don't go overboard with it. Template strings should be your default go-to technique when constructing dynamic strings in ES 2015. Number 2 is about eliminating if-else conditions with hash maps. Now imagine you had a function like this where you're returning the image to show for a weather condition. An if-else block naturally makes sense, but this can be simplified even more. If you notice, what we're really doing is looking at the condition value and giving back a string. Let's move all of this into a hash map. So here you can see that I've created the hash map with the key being the condition and the value being the image. With this little change, you can now return the value by simply looking at the hash map and passing in the condition as the key into the map. You can also handle error cases, as you can see over here, where I'm passing in a bad condition PNG for invalid conditions. By moving it to a hash map, we have taken the runtime if-else logic and moved it into a data structure. If you have new conditions in the future, you can simply add a key value into the hash map. Right now we have very few conditions, so we can keep the condition map next to the function. But if you have lots of them, let's say 100 or 150 different conditions, you can even take this condition map and move it to a separate file and simply import it into this particular place. Since it's a simple hash map, you can even download it from the server as a JSON file. The next one is about converting multiple arguments to a function into a single config object. Imagine you have a formatting function such as format number. It takes in the value, how many decimals to include, whether to add the percentage sign, and what's the prefix and suffix to use for the formatted value. Obviously, there are a lot of parameters over here, and it can be a little cumbersome making sure which parameters to pass in what order. This is definitely a case for converting the arguments into a config object. And that's exactly what I've done over here. I've converted the arguments into a config object and also given them default values. This makes it easier to now call the function with a config object and having named arguments. The general rule I follow is that if I have 3 or more arguments to pass into a function, I'll make it into a config object. Next up is pre-binding arguments to a function. Imagine you had a function called doOperation that takes in the name of the operation and the arguments to pass into that operation. Down below, we have the findSport function that returns a promise. When the promise resolves, we want to call doOperation with placePort and the arguments from the promise. So you can see over here how we are calling doOperation with 2 arguments. Similarly, we also have the getShoppingList which returns a promise. And when the promise resolves, we're going to call the doOperation with buyGroceries and the arguments from the promise. Now the then callbacks for findSport and getShoppingList take in an anonymous function in which we call doOperation. And the reason why we need to do it is because doOperation takes 2 arguments and the second argument is coming in as the response from the promise. We can eliminate the need for an anonymous function with the use of function.bind. Now the bind method on the function prototype creates a new function which has its context pre-bound to the passed in value. But in addition to passing in the context, you can also pass in arguments that you want to bind to that function. So here you can see on line 23, I'm calling doOperation.bind, passing in a null context, and the second argument is play sport, which actually happens to be the first argument of do operation. Now play now points to a function that only requires one additional argument to be invoked. We'll create a second variable called buy and create that by using doOperation.bind and then pass in buy groceries as the argument to that function. So we now have two functions, play and buy, that are only waiting on the second argument for getting invoked. So what do we gain by creating play and buy? Well, now you can invoke find sport and in the then callback simply pass in play. Similarly, you can also call get shopping list and in the then callback pass in buy. And you can see that the function invocations almost reads like English now. Find the sport and then play it. Get the shopping list and then buy. So by pre-binding arguments to functions, you can actually eliminate the need for anonymous functions in most cases. Okay, number 5 is breaking complex conditionals. So what do we mean by that? Let's look at a piece of code like this. So here we have a series of conditions that are being checked for, and when any of them match, we want to show a special offer. Now the conditions themselves are a little hard to read. So let's break them down by giving them specific variables for the different conditions we're checking for. So here is a simplified version. Now you can see that the conditions are actually far more clear. We're checking that if the person is a teenager, or if he's a first-time gamer, or if he's part of an ad network, or if he has some special achievement, only then do we show this special offer. By giving those conditions some intention revealing names, you can see that the whole conditional has become far more readable. So now let's take it up a notch. Imagine you had far more conditions to check for. Instead of giving intention revealing names for each one of them, we can instead create an array of conditions, where each condition is a function that captures the conditional. So here you can see that I'm taking the first condition, whether the person is a teenager, and putting it inside a function which returns a boolean value based on the age of the person. So if the age is greater than 0 and less than 20, then we return a true value from that particular condition. So I'm going to do the same thing with the rest of the variables. I'll capture each of those conditions inside a function and then make it part of the condition array. So you can see that every single function now returns a boolean value depending on a specific condition that it's checking. This also makes it easier to add more conditions into the future by simply putting a new function into this array. Now our original complex conditional was based on an OR of all the individual conditions. So now that we have an array of functions, how do we translate that? So in this case, I'm going to use a helper function from the Lodash library called _.sum. Now sum takes an array of items and a predicate function, and it will stop at the first one that returns true. So in this case, we have an array of functions. So we need to invoke the function, and then sum will stop at the first one that returns true. Let's store the result of that in the matches variable, and if matches is true, only then we show the special offer. So what do we gain by taking this approach? In the future, if you have more conditions to check for, it's just a matter of adding a function to this array. So as an example, if I want to check for an extra condition, which is show if the number of special achievements is greater than 10, it's just a matter of adding a function now where we check for the length. And my sum will loop through the functions and stop at the first one that returns true. With sum, you're checking if any of the conditions match. If you need to check if all the conditions need to match, then you can use Lodash's every function. Every will loop through all of the conditions and return true only if all of them match. Alright, let's move on to the next one now, which is using an inline IFI for complex initialization. So let's look at the piece of code over here. What we're really doing is constructing the default config object, and for doing that, I'm going to read some settings and construct an API URL. So this is the case where you have some initialization code, and for that we are creating some extra variables and also creating a function called read settings for doing that. Now the only purpose of these variables and the read settings function is to construct the default config object. So let's move all of that into an inline IFI, which stands for the immediately invoked function expression. By creating an IFI, we can move all the variables and functions inside and stop polluting the outer scope. This also keeps all the related code nicely co-located and encapsulated. So as a final touch, I can move the read settings as well into the IFI. You can use this technique anytime you want to do some complex initialization. Instead of creating variables in the outer scope, you can move all of that into the IFI and keep the code pretty clean. And for our final technique, let's move on to number 7, which is using hoisting to focus on the important code. The hoisting, as you know, is an interesting behavior of the JavaScript runtime that moves the variable and function declarations to the top of the scope. Now we can use this technique very effectively to keep our code more readable. Now imagine you had a piece of code like this. What we're really doing here is fetching some data from some JSON endpoint, we're doing some transformation on it, and then rendering some HTML. Now this could very well be part of a React component or a Vue.js component or something of that sort. So let's see if we can actually simplify this code a little more. In the first then callback, we are processing the response, which is in the data variable, and then doing some transformation on it. Let's move it to a function called process data. So this moves all the transformation code into a separate function. Now let's take the code that handles the transformed data and creates the HTML out of it. I'm going to call this function as render HTML. So let's take the code from the second then callback and then move it to that function. So with this little change, the code at the top looks much more readable. I can fetch the data from the URL, then process the data, and then finally render the HTML. Now both of these functions, process data and render HTML, are receiving all the arguments they need to actually do their work. So there's no need for them to actually be part of the render function anymore. So we can move them out to their own independent functions outside of the Vue code. So I'm going to do that over here and put them at the global level inside the module. What we've really done over here is taken all the implementation detail, which is processing the data, rendering the HTML, etc., and moved them down, which is below the main entry point of the render function. And by doing it this way, we have made the render function itself far more readable. And since we know that these functions will be hoisted to the top of the scope, they will be available inside the render function. So we can use this technique in every place where we need to hide the implementation detail below the main entry point of your function. So use hoisting to your own advantage. Alright, so those were 7 different techniques you could use to refactor and simplify your JavaScript code. Hopefully, you'll discover several such patterns in your own code and make your code more readable for others and for yourself.